So muss das sein. Dann bitte buckle up. Los geht's. 3, 2, 1. Welcome message. Jawohl, los geht's. Wherever you are, welcome to another installment of the Developer Webinar Series. Today we're going to talk about Knative introductory stuff, and I am very, very grateful that I have two wonderful speakers over here, two amazing Germans, Matthias Wessendorf, who calls himself the Currywurst King or Senior Developer. He's working for our middleware BU, working on messaging and streaming stuff. And also Dr. Roland Huss, a principal software engineer, who's also working on Knative. So Roland, I'd love to give it over to you, but I need to take care for a couple of housekeeping items. So this is supposedly a very interactive webinar. You guys are totally free to ask questions. We have a chat window that you can use throughout the complete event, and I will do my very best to catch up with all questions coming up. We also have a Q&A section to the bottom right of your screen, somewhere there, where you can also put in your questions whenever you have some. This session is going to be recorded, and you can take a look at the recording afterwards whenever it's published. I hope it's only going to take a couple of days. As you have noticed, there's no sign-up requirement, so we can't let you know that the recording is online. So it's up to you to check back in frequently with the Developer Webinar Series website. Did I forgot anything? I don't think so. So Roland, thanks for being here. It's always a pleasure to see you presenting, so I'm very much looking forward to it. Take it away.
Thank you, Marcus. Thanks a lot. So let's get started. So today we are talking about Knative, and Knative itself. It's a Kubernetes-based platform for modern event-driven serverless workloads. So this is quite a mouthful. And before we jump right into Knative, let's talk a little bit about serverless, because if you ask 10 people about serverless, you probably get 10 different answers what serverless is. And so I picked more or less randomly a definition. This one is from the CNCF. And this is a quite lengthy definition, and I highlighted the parts which are relevant for Knative and grayed out a little bit those parts which are not so relevant for Knative itself. So, but let's focus on the important part. So serverless in the context of Knative, it's about applications that do not require any active server management. So you're just deploying your applications which are packaged in a container, and then Knative will manage that for you. And it's a deployment model. This is important because it's not a programming model. So you can put anything what you want into your container. This is a little bit different to FaaS, functions or services, or functions which are more also implicate the programming model. And with Knative, you're executing. So you are really focused on the demand of your application, so on the number of requests your application gets. And those are executed, scaled, and built really corresponding to the demand. So actually, when there is no demand, then you don't have to pay anything, because then your application is not running. Okay, this is a very brief. We'll see more of that in detail later on. Here that guy, of course, it's a kind of a joke about that. So what's the difference of serverless with CGI? And this is actually more, poking on the fact that really serverless is quite a fuzzy word which is has no clear boundaries. So maybe you can convince him why it's not really only CGI. So Knative is for sure a little bit more than CGI.
Okay, this is what I started my programming career with. It's like Perl scripts, right? So, and they tend to be very function oriented. So I think to a certain extent it is a good comparison.
Yeah, but actually it always focused on a single machine. So I think this is the main difference between the good old CGI builds from the time there. So fair. But actually you're completely right. So it's really something you throw a code over the fence, and then somebody is running it. And this is a little bit like the CGI builds, right? Okay, but let's continue with Knative now. Now, what is Knative? So let's go go to the definition, how Knative defines itself. So Knative is a Kubernetes-based platform to deploy and manage modern serverless workloads. So it's really about deploying and managing stuff. And it contains two components. These are really the kind of pillars on which Knative is built upon. So it's serving and eventing. The serving part is all about a request-driven model that serves the container with your application and can also scale to 0, which means you can scale down so that no pod or container is running for you. And when the first request comes in from the outside, then Knative will spin up the pod for you and serve the request. The other part is about eventing, and Matthias will talk about this later on. And it's about the common infrastructure for consuming and producing events that will stimulate your Knative services or applications. So the one thing is about really serving your application, and the other part is about how to connect this to the outside world via eventing. Let's have some look at some background information. So where is Knative coming from? So Knative has been started mid-2018 by Google as an open source project. So it has been started from scratch and contains a lot of experiences that Google has gained over the time with operating serverless applications. It's community driven, but has also a lot of vendor backing. So actually there are quite some companies which are involved in this project. So of course Google is the initiator, but also Red Hat is one a big contributor to Knative, IBM, VMware, Trigger Mesh, SAP, and many more. Community-wise, it's organized in multiple working groups, which have weekly meetings. And you find here the link to the Knative dev and also the GitHub archive, and you find all of this on these pages, a lot of documentation, also examples. We are currently at release 0.14, and Knative has a 6-week release cadence, which means you get every 6 weeks a new release from Knative. Good. Then let's, how could you try yourself Knative? Of course, this is one of the very important questions because it's quite easy to set up. So you can use it directly on given Kubernetes cluster. You can use any Kubernetes cluster if you like. You find the installation documentation on the Knative dev website as well. But you can also use a hosted version of Knative. And there are two prominent offerings which you can use. One is called Google Cloud Run. This is funny because it's not really running on Kubernetes, it's running on App Engine. And you can try it out. There's a free tier you can try, but it's important to know that not all Knative features are implemented out of the box. For example, you cannot use config maps for the configuration, other stuff. This is due to the nature that Google Cloud Run is based on App Engine.
Hey, Roland.
Yeah.
Is there a way to try out OpenShift serverless on code-ready containers? Do you know that?
Yeah, you can try that out as well. So OpenShift, so you see OpenShift serverless with the offering from Red Hat. You can directly install it from Operator Hub, and this is also included in code-ready containers. So you can try this also on your local machine if you like to. But of course, you can use any OpenShift cluster and install the product. And it's a good question because I can show you how this looks like from the OpenShift console. So here you see it's an OpenShift 4.3 cluster here, which you can use. And if you know OpenShift, you also probably familiar with the Operator Hub. And then this is the more or less breaking news because we released the OpenShift serverless operator here. I think 1 week ago, Matthias, I think it was 1 week ago, right? A GA. So you can install it directly from the Operator Hub, and then you have this operator running here. You can have a look on the installed operator, and as soon as this operator is running, it takes care of everything what you need to operate a Knative installation. And now we are using this cluster now in the demo later on, where you can create your Knative services right here. So this is very easy to set up. So if you're an OpenShift user, this is really the perfect way how to try it. And The good thing, of course, as OpenShift Serverless is based fully on vanilla Knative, there are only the operators which has been wrapped around the Knative installation. You can benefit from all Knative features which are included. Okay, so now we know a little bit about Knative. We know how we can try out Knative, and now let's jump onto serving, the serving part. What is Knative serving all about? It's all about routing, scaling to zero, and tracking revision history. What does this mean? So it's about that you can scale to zero. I already mentioned that. It's demand-based, so it's not based on CPU or memory usage, but really on the number of concurrent requests coming in. So it's really really connects to kind of a business metrics. It separates very clearly the code and the configuration, but Knative is not suited for every application. So it's only really suitable for stateless applications, which have some restrictions. This is due to the fact that you really need a flexible way to scaling to zero and scaling up. And so what you need to do if you have a stateful application, you need to try to move out the state outside of your application, for example, into a database, or also with the browser which comes in with some cookies or something like that. Now, this is an important restriction which you need to know. Then it also has a rich traffic split up capabilities, which allows you to model a lot of different custom rollout strategies of new versions. You can easily create your own blue-green deployments or canary deployments with this traffic split capabilities. We will see an example later in the demo as well. So the resources. So this is something. So Knative itself runs on top of Kubernetes, and this platform contains several so-called custom resource definitions or CRDs, which is the way how you can extend Kubernetes by adding new types to the system. The important types here, the most important type here is the service, which is the user-facing type. So if you interact with Knative, you always use the service. And as soon as you create a service, then a route and a configuration object are created on behalf of your service. So it's really a one-to-one relationship between a configuration and a route and the service and the route in the service. And anytime you change the configuration of a service, then the configuration is updated and a new revision is created reflecting the state of your configuration at the time. So with this mechanism, you can build up a complete history of your configuration, which allows you to do nice things. Like, for example, you can have a revision reflecting your version 1 of your application because it contains the reference to your container image in version 1. But you also can have then a revision which points to the version 2 of your application. And then you can create a route which makes a kind of a traffic split and which distributes the traffic among these two revisions. Okay, so these are the basic objects, and actually this is all what Knative serving is about. And also why is this model so appealing for a developer? Because it makes things also simpler. It's not only about autoscaling, but you can also very easily create your application and deploy your application. What you see here now is a deployment. If you know Kubernetes or OpenShift, you know that how a deployment looks like. A deployment has a very lengthy specification here. And if you compare the corresponding Knative service, you see that it has a different API version, different kind. And a lot of things has been left out. So, for example, everything which is in gray here is not needed on Knative service. So it's just here to show the difference to the deployment. And it's much easier, simpler, but more importantly, it not only creates your deployment for you, but also the Kubernetes service and the ingress or route object, which also created on behalf of you. So if you deploy a Knative service, then a deployment is created for you, a Kubernetes service is created for you, and an ingress and route is created for you. Yeah, here we also see that a little bit of problem with the naming, because you see here service and K service in the title. And this is a little bit unfortunate that Knative also has chosen service as the name of its entity. because there is already a Kubernetes service, but both of those are totally different things. So one is really, so this is important to keep in mind. Okay, so I have a little bit now a short demo, 5 minutes or so, and we will see that in action. Let me jump to the terminal. So what I have here is now I have my terminal, I have a connection to the cluster that you just have seen. And in the top of half of the screen, you see a watch on the pods. So you see all the pods that are created in my namespace. And what I'm going to show you now in this demo is also the Knative client tool, which is called KN. You can download that from the Knative website. You can use Brew if you're running on macOS. So that's several ways how you can install that. And all what this tool really does, it creates the custom resources for you and then deploys it to the cluster. Later in the eventing part, Matthias will show you how to do this with the deployment descriptors, with YAML. But for us, we are just using KN, and let's create a simple Knative service. So you give it a name. It's called random here, and the only mandatory option which you have to provide is the pointer to the container image. So I'm using here a REST service, which I called random, and it's a very simple REST service which is based on Quarkus, and which returns to you just a random number. Okay, let's do that. In the top, you will see now that there's a pod is created for you. This is your application. So if first time you deploy a Knative service, the pod is directly created for you. And here you see a little bit is also going synchronously. And at the end, you get the access URL. So I can't just use that, and I use JQ to make it a little bit nicer. And you see what comes back is here really just a REST response with the version and the random number. And if I call it a second time, you get another random number. Okay, and if I'm continue talking, you will see that because I do not send any traffic on this image, then it will scale down to 0 easily. So you can look into the service describe. And you can service describe is something where you can get a presentation of your service. You can look at it. You also can export it into YAML, so you can easily also see how it looks like behind the scenes. Here you see it's really quite shortish. So if you compare this to a full deployment, it's really a little bit more dense. And also, so I'm jump to the top. You can also look at the revisions. And as you have just created the service, you see here that there is one revision there. First generation gets all the traffic here. This is important. And now if you look at the top now, you see now because I have talked so much, so I talk longer than 1 minute. This is the default value. Then the pod scales down to 0. So if there's no request within 1 minute, it's scaled down. Your Knative service has no pods running anymore. Okay, let's make an update. Update random. What I'm doing here now is, next step I'm showing you at the parallel concurrency. So I can update a service. I set a concurrency limit at 10. This means as soon as a pod gets more than 10 requests at a time, then Knative service scales up the number of pods. You see this in action in a second. I'm also changing this autoscale window of 60 seconds to 6 seconds, which means that it will scale down after 6 seconds when no request comes in. And I'm introducing an artificial delay of 1 second or 1,000 milliseconds so that I can simulate some kind of work on the cluster. Let me do that. And yeah, you see it's again, the container is created. And the next step is I'm using Hey, which is a little small command line tool to make some kind of simple workload testing. I'm using with -C50, 50 concurrent requests, and this 1,000 times directly to my service here. I'm starting that to make it a little bit larger. And now you see that more and more containers are created. So they are running here now, processing the requests. And you see also that there are more than 5. So actually I would expect 5 containers because I have 50 and I have 10 concurrent requests. So in order to have 50 parallel requests served by that pod, there are of course, is 5, but a little bit more because Knative decides to already scale up earlier before it gets the full utilization. So it's below 100%. Typically it's around 70%, but you can tune this percentage as well. Okay, and now after 6 seconds, you see again that all your pods are really scaling down to 0 and everything is gone afterwards. Okay, I have a final example, which is about how you can make a rollout. So if you look again at the revision list of our service, we see now that we have 2 revisions. So one is our initial revision, this one, and then I changed some parameters and I get a second snapshot of the configuration of the second revision. So 100% of traffic here. I make an update. Again, now I'm tagging this revision with a label called v1. So we can see again the revision list. We see here now the tag v1. And the next step is now I'm rolling out a second version of my application, v2, and now make a traffic split directly to v1 and v2. For that, I can use again K and service update random minus image. So this is my sorry, I jumped to the top because I have some 1 second. So see here. So you see here the image is called version 2.0. But then I make a traffic split. So I use minus traffic latest 50. This is always the latest deployed version. So in this case, it's then version 2. Gets 50%. And then I have v1, which is also 50%. And then again, okay, this autoscale window, I set again to a little bit higher. So I'm not sure why my outs has been broken. So I set it again to 60 seconds so that it's not so dynamic. Okay. So I'm using a 50-50%. Of course, normally if you're in production, you would use something like 90-10 or 10-90 so that you make kind of canary deployment. So you roll out your new version and only set it to 10% of traffic so that you can try out stuff. And but for the sake of demo, I'm just using a 50-50 so that when I'm going now I jump again to the top here, we're going to curl. Again, I see here, so let me use -s. So we see here version 1, next one, again version 1, so but over the long run, again version 1. Now we have version 2, you see here version 2. And so of course, if you have a large number of requests, then the distribution will be around 50. 1, 2, okay. So, and as you said, you can really create a lot of very flexible rollout strategies. You could also do blue-green deployment to say, okay, I'm just firing up my new version. And then you switch over completely from 100% to the new version after everything is up and you have tested it. Because also every revision you have has also an old URL, so you can test your revisions directly without going over the service. You see this, for example. So this is also my last service revision list. We have here again it's a revision list. See here, for example, we have that one, and then I can say revision describe random. You see here, oh, it's not shown here, but you can directly use. Let me try whether this works. Not. You can use here the name of your v1. Okay, no, but there's an URL, so I have to look up this again. Okay, let's go back to the slides, and this is also all of what I have about serving. So, yeah, I hope now I hand over to Matthias for eventing demo, and now you learn all about the goodness of eventing. Thanks a lot. Any other questions?
No, I haven't seen anything. Just a gentle reminder, if you have questions, feel free to put them in the QA window or chat window, which is somewhere in the middle of your screen. We're here all day. So, and if that is not enough, also find me on Twitter. That's my fear. And DMs are open. So if there's something that we can answer, I'm more than happy to pass on the questions and get you the desired relief and answers. But now over to Matthias. Hey, Matthias, what's the story behind that title, like the curry wurst king?
That's more a joke.
A joke. Okay, I thought you like barbecue and stuff like that, but may I have seen some pictures of you doing barbecue last weekend in your garden?
Sometimes, every now and then,
Sometimes.
definitely
Fair enough.
specifically with
Your show now. Tell us about
All right,
eventing.
great. All right, yeah, welcome to the second part of this Knative introduction. Roland was covering the basis of Knative serving, and in my eventing specific section here, I'm going to leverage some of that because I use Knative eventing to actually populate services that were deployed as Knative serving services. So Knative eventing, as Roland was already saying, is one of the two biggest parts of Knative overall project, and to some degree you can summarize the eventing project. You can see it as a universal kind of subscription and event delivery and management of events. And very, very important here, it's all really based on cloud events, which is the public digital standard from the CNCF. So everything that we will see and everything that we will do within Knative eventing is really based on a public standard called cloud events. Knative eventing, as I was already saying, is based on cloud events. It's really important to actually underline it again. That's based on an official standard, so that is also very important for interoperability with other systems. So for instance, if your existing application is interested in emitting some events, let's say to some part of Knative, you can just exchange it and have a vanilla HTTP call to the Knative components. It is a very pluggable mechanism for the overall event delivery. It has the concept of a channel. There are different implementations available in the Knative ecosystem. The in-memory channel is kind of the toy that comes with Knative eventing as the default choice. However, you can also pick a channel implementation that's based on Apache Kafka. There's also alternatives that are leveraging messaging infrastructure from the Google PubSub project. The specific routing from events to a different thing is done through YAML configuration. And the really interesting part here for the integration with third-party systems is a source. So you can easily develop your own source where you can call into your own legacy system, for instance, or into your specific database or whatever kind of third-party system you have. You receive the events and then you emit them as cloud events to the Knative components like the sinks. And in our case, the sink is an addressable that is consuming cloud events. And in our specific cases here for the demos that I have later, they are all written as Knative services. However, you can also use vanilla Kubernetes services, but they don't have the nice autoscaling stuff that Roland was explaining before. However, you could, for instance, have a Kafka source that is emitting to a good old Kubernetes service as well.
Hey, Matthias, as an old Java guy, I'm kind of thinking JMS. Is there like a comparison to what I already know, like queues, topics? Is that how I should think about cloud events in general?
Not specifically in that sense. Knative is more like as a universal system for, like you could see it as your eventing mesh, like different components produce messages and deliver them to the system. And later on, I explained a concept that's called the Knative broker. And with the broker, you have some kind of trigger where you can do some kind of filtering based on the metadata of the cloud event. But I wouldn't not really compare it so much with technologies like JMS. JMS on the protocol side is proprietary. Every system uses their own protocol, so there's not that much great interoperability. But here, the protocol or the wireframes that are on the protocol side is HTTP and cloud events, so you have much more standardized approaches there. So you can't mix and match different JMS implementations. So if you use vendor 1, you have to use vendor 1's API. You cannot combine that. And here it's really through a real official standard, not the JCP standard as an API compliancy, if that makes sense.
It does. Thank you.
All right. Channels and brokers, a little bit more advanced topic, really important for the actual integration, and that's the biggest exposure for Knative users is really, we have a pool of different Knative event sources, and they allow you a nice way to actually integrate your third-party systems with Knative. So for instance, you could write your Java application using Quarkus, for instance, and call into your database, receive those database events and turn them into cloud event objects, and then you emit them to the sink that is injected, which at the end of the day would be just an HTTP URL where your source would perform an HTTP post. Most of the full-blown sources, they come with their own custom resource definitions, so they are very declarative when you create them, and some of them are actually running through an operator. You can have different integration models there. You can have either push or pull based. For instance, we have a Kafka source that I'm going to show you later, which gets the messages from the broker, but we also have in the Knative eventing ecosystem, we have a GitHub source. So the GitHub source is based on webhooks that basically inform your cluster source that there was some new traffic on a certain pull request. And the kind of requirement that all of these sources have is they basically convert the third-party or proprietary event format into standardized cloud events. So it is easy for consumption on different languages and different systems, etc. So you can have your Go-based source, which is delivering events as HTTP cloud events to a Java service that is doing the consumption. We have a few sources built into the Knative project. So as in Knative eventing, the main repository, we have a ping source, which is kind of similar to what you could do with a cron job. It has a schedule and we can send some messages that we will see later. There's an API server source, which is interesting because it turns the Kubernetes API server platform events into cloud events. So you can basically receive whenever is a pod started or whatever. And there is a sync binding and a container source. The container source is a kind of meta approach that you can basically create your own, bring your own container and stick it into the official container source YAML. Very similar with sync binding. It's a little bit more abstract there, but both are actually allowing you to bring your own kind of container and make that usable with predefined types in Knative eventing so that you can have your Python, JavaScript, or Java source integrated as a kind of Knative eventing source instead of writing a full-fledged operator and CRDs and whatnot. And then there's a Knative contribution repository. There's a bunch of other stuff. For instance, I mentioned the GitHub source already. I mentioned the Kafka source that we will see later in action. And there's also integrations using Apache Camel. We have a Camel source, so you can run all of your integrations with the DSL that you know from Apache Camel and can deliver messages from Camel to any service consumers there as well. Now, with Knative, we see three big areas of use cases. Let me start with the first, most simple one. There is a one-by-one connection to a Knative source and one Knative service using as a sink here. So there's a direct connection. And this is actually the most simple way to get cloud events from a source to your application that is consuming these events. However, there is a one-by-one connection, like a direct connection from the source to the service. That means there's a little bit of drawbacks here. So there's no back pressure support or no active queuing support when the service is not available. And only one service can consume that event. So if you want to have two services that want to consume the event, you would have to kind of scale up. You need a second source and you need a second service. But again, this is the first way into Knative for consuming. And there's also no specific filtering here around the sink that is tied to exactly one source is getting all of the events. And I have a little demo here for you. let me jump over to my terminal. What I have prepared here already is two files here in my folder. One is a event display, which is a Knative serving service. Let me just quickly show you what the YAML looks like. So it is API service for serving. Is a kind of serving. I have it in name. It's a display, and I bring my image here. It's key.io, matz.w, and then event display. So this is my, in our case, Go application that is receiving events. Now this thing is already deployed, but there is no traffic to that particular Knative serving service, so it's not yet scaled up. However, let me show you what a ping source would be looking like. So ping source has the API version here, sources, Knative dev, and then v1 alpha 1, and it's a kind of the ping source. And here we have a name, it's the test ping source in our case. And what's really important here is inside of the spec object, we have that schedule. So every minute we get some data here, like hello Red Hat developer, and then all of the events that are created from the source are emitted to a sink, and we use a destination here for my ping display, which is a Knative serving service. Let me apply the file, and what we will see is that hopefully a pod is starting up. It is starting up. So this is basically the ping source that I was naming test ping source. And we see here the container is being created. And then soon, once the container is up and running, the ping source itself is working based on the schedule that we were having there. Like every minute there is one message. So now we have to wait a little bit here. And whenever the ping source is actually creating based on schedule and the payload, so whenever it is creating it, it is emitting it to my already deployed service. And then the Knative serving activator goes in and fires up a Knative serving pod for me. And then eventually when that thing is there, the message is distributed to our, what we see here. We can now take a look at the log when the container has been started and is fully created. So we should see a message that says, hello Red Hat developers on the log console. Let me do that here. I need a log. I provide the full name of the pod. And then as you can see, there is two containers, and we are interested in the user container here. So what we see is here a little bit of emoji. I print out the entire payload of my cloud event here. So it has some specification version, it has some type. So the type of the source is a ping source. I have like the source where it actually came from the event, like the event source is my namespace default here, ping source, etc. It has an ID, it has a timestamp, and it has data content. And then in cloud events, it's specified that all of the data comes inside of the data body there. So every minute there is an event. And now I was talking over a minute, we see the second event here. Again, it says it is a valid cloud event. It has some nice emoji on there in my logger. That's pretty much the first hello world kind of experience with Knative eventing. So the next step is a little bit more flexible. So the source to service delivery is now done through the concept of a channel, which is basically an abstract mechanism for receiving data and then delivering data, but on different principles here. So multiple services can basically consume the same event with this one, and it's done through a subscription. What we see here on my slide deck on the left side is I have now two sources that are both emitting their events to the same channel, like one channel object, but now I have two subscriptions. So my first service here is receiving all of the messages, and the second one is receiving the same type of the messages. So this is a little bit more flexible. I have also the opportunity to bring in a different channel. I don't need to use the default choice of the memory channel. I can go with an Apache Kafka channel. So if you deploy the channel, behind the scenes, the controller for the Kafka channel is creating a specific topic with a specific setup like replication, factors, and participants as specify them when you set it up. But that's all taken care of for you. So you submit messages to the channel, and then with the subscription, each subscriber gets the same messages. So there's still a little bit of drawbacks there. It has some kind of infrastructure needs because, as I said, if you're going with a Kafka, you have to have a Kafka running somewhere. And still, there is no filtering because every subscribed service is basically receiving all of the events. And the last, more universal, is really the source and service delivery through a broker and a trigger. And this is really a nice way to see all of the benefits from Knative eventing. Basically, you use the Knative broker as your eventing mesh for distributing all of the events in your specific namespace here. What we see here is I have a green source and I have a yellow source, and I have a few events emitted to the same broker, the Knative broker. And then I have not really a subscription as I had before. It uses subscribers behind the scenes, but this is a trigger that I've deployed here. So the first trigger says, hey, little broker, I'm interested in all of the yellow events. So this service is not getting every event on the broker, it's only getting the yellow event. And the trigger here for my second service is saying, hey, I'm only interested in this greenish event. So he's also just getting the green one. So 3 events go into the broker. 1 is going to my second service, and 2 of them are going to my first service. So I have a fine-grained way to actually trigger event delivery based on attributes of the cloud events. So I was using the type filter here. So I said the type is a yellow event and the type is a green event. So I have some kind of content-based routing for my services here. A little bit recap on the concept. So the broker is really the universal delivery system, or I really like to call it the eventing mesh. And it does connect sources with different things. And behind the scenes, it is using the channel implementation. And it is creating it all on the fly just for the user. There's like, if you use the vanilla configuration, there's no setup needed. With the latest release, we also have the opportunity to use a multi-tenant broker option so that there is a broker running in a global Knative eventing namespace and not in your user namespace where the program is. And then the trigger is really the driver and the routing component here. So it filters events based on the type or based on the source. So if you have a few different sources providing all of the same cloud event type, you can filter, I want it just from source A or just from source B with the type of blah, blah, blah. You can also easily, as I was saying earlier on, with your existing applications, you can deliver messages direct to the broker and feed it in there, and then the trigger also would still apply to everything that's available on the broker. And the trigger can also basically produce new events and return them like as a reply to the broker, and all of that. And that again is very, very important. It's all done through standardized cloud event objects. So there's like really big interoperability with multiple vendors and multiple programs is possible here.
Matthias, maybe I have a stupid question, but maybe it's not. So you're talking broker, right? So what is a broker, and is that part of Knative or?
Yeah, the Knative broker is really the eventing mesh. That is the thing that is distributing all of the events based on the trigger. It's not really related to a broker in the sense of the messaging brokers that you may be confused with. However, the broker uses a channel underneath the scenes for the distribution of all of the messages. So if you say, I want to have a Knative broker, it gives you an object of the broker in a per namespace. And behind the scenes, it is using whatever is the default setup for the channels. And the channels are those that actually manifested the transport behind the scenes. So the broker really here is just the delivery mechanism, and it is running all of the triggers to actually perform the content-based routing.
That makes sense. Thank you.
Okay. But I can show you in action as well. I have one more demo here for you guys. Let me jump to the terminal. Okay. So I have prepared something here that has a little bit more complexity. Before the demo, I was already installing 2 different Knative serving services, one that is called Kafka Broker Display and one is called Ping Broker Display. They will be eventually used for consuming all of the message. And in order to instantiate my broker, I would have to label the namespace. So I'm going to use my default namespace here, and I provided a label called Knative Eventing Injection Enabled. And now what you see is two more pods will come up. So two more pods will come up for the broker. One is actually the ingress of the broker, and the other one is for the filter of the broker. And those two pods in combination are basically the broker that I'm going to use here. Now, the services, they are already applied, so they are already actively running in my namespace, but since there was no message delivered by the broker / trigger to either of these serving services, none of them are now running. Now, let me take a look at the different sources that I'm using here that are emitting their events now to a broker instead of to a directly tied and coupled service here. Let's start with the Kafka source. The Kafka source is in the same API version group here. It is sources Knative dev, and it has a kind of Kafka source. Here I give it a name. And then inside of the specification, that's what really interesting here is I gave it a consumer group. In my case, I'm using demo. And here I'm using the cluster that I have installed locally on my OpenShift instance here. I'm using Strimzy or Red Hat AMQ Streams here. It's running in the Kafka namespace, and my Bootstrap server, that's the default setup from the Strimzy project, is this URL. And I'm having the topic, so the source is listening to one topic in our case. Topic is called my topic. Now, the important difference here between the previous definitions is that the sink is now no longer a Knative serving service. It is the broker, and it is the default broker. And what we see here is the pod that I was creating here based on my labeling is actually that different default broker running in my namespace. So all of the events that are coming from the topic to the source here, to the Kafka source, are being transformed or being distributed broker and later on for consumption. Let me apply my Kafka source here. And I made a change to the ping source. So again, here we have the test ping source. There's no modification in terms of the payload. However, when I apply it, I basically reconfigure the currently running ping source, and I will have the events from that source going to my broker now instead of the Knative serving service. So the ping display will eventually go away because it will no longer receive any message, because the reconfigured version of the ping source is going to emit all of its events, like every minute one message, to the broker. Let me apply that file as well. What we see here is it doesn't say created because I just changed it. And here we see a new pod is coming up now that is representing the latest configuration. And when this specific pod is actually running, we will see the old guy will be terminated. And then this instance is no longer emitting the events display here, and that will go away. Okay, so what we have here is we have two sources configured to emit events to the broker. However, we are not yet consuming them. So this is where all of the magic comes in. And the broker is really just a black box concept. The user usually doesn't have to deal with it that much. It's more an interoperability through the triggers. Now let me see the triggers for some event filtering here. So for instance, how can I filter events from my Kafka source? So this is basically the API that users are mostly interacting with. So there is a kind trigger that's in the eventing namespace. And what is interesting here inside of the specification, I say I want to listen on the default broker, and I want to apply a few filtering rules. So I have a filter based on cloud event attributes, and every cloud event does need an attribute called type. And in our case, with the Knative Kafka source, the event type for all of the Kafka events are actually dev Knative Kafka event. And then it is basically delivering the events to the interested subscriber, which in our case is a Knative serving service called Kafka Broker. Let me apply this trigger. All right, and now let's take a look at the other trigger that I have in here. So what you see already here is above in the schedule with the pod. I was talking a little bit longer here, and I have already prepared a lot of dumping messages to my Kafka object, to my Kafka topic. So there's a lot of messages already in that topic. And based on the scaling facility that Roland was explaining, now Knative sees there is messages delivered from the broker to the different Kafka display here. So it's creating a lot of different pods there, right? So Knative, the autoscaler, is basically ensuring that there is a lot of instances of my Knative serving available so that they all can receive messages there. Let me take a quick look here. Oops. What the logs would be looking like. Go in here. So in the background, I have prepared a application that is basically receiving WebSocket events from the University of Newcastle, and is turning these WebSocket events, turning them into Kafka objects, into Kafka messages. And my cloud events that I see here is basically the transformation from the Knative source for the Kafka source. So again, I have some emoji here in my display. It is a valid cloud event, and it has some context here. Here's a different type, Knative Kafka event, and you see already it's catching up with the messages. So similar to the example from Roland before, when there is a more when there is less traffic, it will basically reduce the number of active deployments. But here, it has some cloud event values here. So again, specification version for cloud events is 1.0. It has a source like the origin. It comes, so the events here come from my default namespace and come from the Kafka source, which has a name and which is bound to a specific topic. It has some subject that is an attribute specified in the cloud event specification. In our case, we see this is message number 719 on partition number 57. We use some cloud event extensions are we using here. So basically the message was hopping through different channels as the broker mechanism was playing with it. So we see here that there's a Knative history. So it came through a trigger-based channel before it was actually delivered to my service. And then here I see some data that is just some JSON data, which is basically the exact payload that I would receive from the WebSocket service that my background application is hammering data to. Okay, I have a second trigger. Okay. That I'm applying now, and I can walk you through this as well. So what I have here is I have a different filter. I'm basically saying I'm only interested in events that are ping, like Knative, dev Knative sources ping, and then it is routing these events to a different service. So let me apply that. I have already applied that, and I guess I have too much messages here.
And not enough time left, so.
Let me just quickly see if I get a pod there, but I think I was having too much messages. Here, okay. So we have one instance here of the broker ping display. Let me just quickly show that to you as well. And then docs -f. And then you can see that actually this guy is only having the messages for the ping source. Yeah, there's no Kafka message in there. We have seen this before, similar context as well. Now it went through the broker. So we see the extensions. That's the difference to my first example with the ping source. So we see as well how it was transferring through the cluster. It says it came from the channel behind the broker, and there's some time of arrival when that actually was delivered, etc. And there's some tracing information here now as well. Yeah. So this was the filter for the ping message, and the other one was the filter for the Kafka messages. And that basically was my demo. A little bit more. There's a few more types. There's the event registry, which is about discoverability of events. So you can specify them on the sources and through event type so that you can actually have the developer know what kind of events are available for me to consume. And there's some more concepts that allow you to basically have some chaining of different services or branching events with different filters. That's called parallel, and the other one is called a sequence. And that's probably it with the full-blown Knative eventing demo. Lots of Kafka messages flying around there.
Nice. Thank you so much. So unfortunately, we don't really have any kind of questions. So I assume that everybody's happy. Again, if you want to rewatch, this session is going to be recorded and published on the same website that you got the calendar invite from. Is there anything else I wanted to talk about? Yes, just briefly mention there is going to be the other way around. There's going to be a new session with Torben Jansen talking about Hibernate coming up June 16th. Website's going to be updated very soonish. Make sure to also reach out to Matthias or Roland or myself on Twitter if you have any further questions. And yeah, unless Roland wants to have the last final words and ask some more questions, or Matthias wanted to say something else, I guess that's been it. So thank you so much for attending today's session. And I'm very much looking forward to hosting you again. So have a wonderful day. Stay healthy, everybody, and talk soon.
Thanks for having us. Bye-bye.
Thanks. Bye. Stay safe.